Well, this is my attempt at my solar powered air conditioning. If you saw my video on heating this room and why I wanted to heat this room up here, this is my little back room. Um, well, it worked fantastic for the winter time. But I also mentioned I was working on a cooling system because the heating is great, but not when it's 80 some degrees outside. So I went ahead and put together this Peltier module air conditioner here. Now I've seen enough stuff on the web out there. There's just it goes from the inconceivable to the impractical and whatever in between. But I have experience on using these modules before. I made a beer cooler, a cool chest, and it will actually have ice form on the fins of the Peltier, the cold side, but it will also turn my just cans of water into slush sometimes. So I know it, and that's only running on a 100-watt panel. What I had for this one, I had these panels gifted to me last year, and these are timed on a timer that move, track the sun across the sky. However, I have added this little tracker system to it. It has not gotten full control. I'm still using the timer, but this little thing will tweak at the end of the move, a time move, and then this sensor will look and say, "Oh, I need to adjust it a little bit," so it'll adjust it one way or the other. This is a pyrometer I had on there earlier just to measure the intensity. It's basically just two of these pyrometer op amps. Um, I did post these on Thingiverse on my OT and AT channel, and even the artwork and how to build these things. So if you want to go there, if you want to find out more about them. But the whole thing is, I'm really only working with 500 watts from my PV panel. So, and the direct conversion for 500 watts, theoretically, if the perfect conversion, I'm only looking at 1705 BTUs. That's not much. You're not going to find an AC system that small. But this room is just a perfect thing for it. It's about 8 foot by 7 foot, and it's insulated. There's no windows here. This machine I had originally was light sensitive, and so it was kind of worked in the dark to keep things constant. So I thought, well, this would be a great thing to play with, and it has been a good success. I have to say, when you walk in this room and it's running, you know you're walking into an air-conditioned room that's not only colder than my shop, but drier because it actually dehumidifies the air. So anyway, let's go back to I'm only working with 1,705 BTUs. Of course, that's the from direct conversion to watts. Using these Peltier modules, I mean, their efficiencies are across the board. And how are you using them? But usually they're low. No matter what you're looking at, they're low. However, they don't even talk about too much efficiency. It's more a coefficient of performance. And you can moderate the efficiency. I mean, the temperature difference in the hot side and the cold side, and how many amps you're supplying. Um, Actually, I measured my amps on my amp meter here, and I've got 30. I run 30 to 32 amps I'm putting into this system. So yeah, it draws a lot. I'm using 10 gauge wire coming from the battery, and I actually had to double that up because it was getting warm. And something else I've done too, I've tried to reduce the heat gain here as much as possible. I'm using a Rhenology battery charge controller, and that's not in this room because that generates heat, so it's outside. But I have to say this has been an interesting experience, and I really like how it's turned out. This is what I'm using. These are these. It's a water block that's attached to the thermal module, and then there's a cooling fins in the back. And there's 4 modules in each one, so I got 8 modules I'm working with here. And there's also little fans in the back. I'll show you other viewpoints of this, but you can see I wrapped everything in aluminum because this thing generates water. I have a 5-gallon bucket just catching the drips here, and it'll put about a ½ inch of water in that during a day. Yeah, that's the air, that's the humidity that came out of the air, making this room even better. So this is another view here. This is the underside view of it. Yeah, and these are 2 different modules, got from 2 different manufacturers, but they seem to be basically the same thing. I don't think these fans are the highest quality fans. I've been, and when they do go, I'll replace them with a little bit quieter. I don't know if you can hear this over my noise canceling speakers, but they're these fans here. Um, on the other view here, this is the back side. These are all wired in parallel together. What you don't see here are the 10 amp wire coming from my solid state relays that powers this thing. And this whole thing gets mounted on the wall. There's these 2x4s that put up here. And there's this airspace for all the wiring behind. And I've removed this. I have this aluminum foil here, and that's covering this whole area up here too. That helps to channel all the air down, because I have fans on the top blowing on top the existing 8 fans, just to kind of force the air down and get rid of the heat. What this rat's nest wires here, these are these Dallas DS18B20 temperature sensors, and I really like using them, and I think that's the key to the system. I can tell exactly how hot the hot side is, how cold the cold side is, and how hot the water coming back to these from the radiators to these heat blocks here. So that really gives me kind of an idea of how the whole system's working, and I'll go into just a little bit more detail. This is the I tell you, the heating was much easier than this, but this is what I had to do to make this system work. Here's these 2 blocks I have mounted, like I talked about, and you don't see these are the 2 wires you do see from the Dallas temperature sensors. There's 2 more behind this, and also 1 more leading down in here, about here, and that actually tells me the temperature coming back from the radiators. So what we have here, I have solid state relays that power this thing, and even though these are 80 amp Chinese made, they don't do 80 amp. You have to do about 1/4 the rated. I was actually putting these 32 amps into one of these rated at 80, and it was already getting too hot. So actually I just split them up. This one side here, this solid state relay controls 1/2, and this one controls the other half. So I can shut them off if I want to, but I've never had to. This other solid state relay here, this controls my solar pump I have down here that recirculates the water continuously. And these other smaller solid state relays, these are the ones that control my fans, both here on the module as well as out on the radiator. I'll show you the pictures of that too. There's another pump down here. This is the charging pump, because I like these solar pumps. They're just, you can hardly even hear them run, they're so quiet, but they're not self-priming. So I have to use this system down here to actually, these are self-priming pumps. I'll open up these valves here, and then it will just kind of run through the whole system and purge the airs and all this too. And this is actually what this tank is for. It not only does it function as kind of a poor man's expansion tank, but also as the small bubbles come through here, it will actually bubble up, and after a day or two of running, you won't see any more bubbles. I do have a 40 amp fuse protected here. This is coming, these 2 wires are coming right from the battery to my bus up here. Okay, I think that's it right here. The a little bit close up of the tank here. This is just something I got on the web. It's kind of an overflow tank from a radiator. I had one from a Volkswagen I threw away years ago. That's a warning, don't throw anything away, you know. I do have an off-on switch. Again, I doubled the wires up here. This is just the master off and on, so I can shut everything down. A little close up here on the printed circuit board. Now, I do have I've not posted the artwork of this. Now I'll go through a little bit how it does, but I do these in modules. This is an Arduino Nano with a real-time clock on here. I'm not using the clock yet, but I can say, you know, start and stop. It does have safety features built into it. If the voltage drops too low in the battery, the whole system shuts down. If the sensors on the hot side of the Peltier module, if they go over 120 degrees, that shuts down, because I've already actually burned out a couple modules. When I ran my plumbing outside, it worked great. I'm just using vinyl plumbing, but the minute that plumbing got hot, because it had hot water running through it, it had one area that had a little bit more pull than it should, and it kinked. shut down my flow, and I touched that hot side before I had my sensors on and burned myself. And the other side was not that hot because a couple of the modules have already burned out, unfortunately. But I did replace them. They're relatively cheap to do, and the ones I replaced actually are better. That side shows better productivity than the other sides. I'm gonna have to replace some other modules too. This is the readout. Now this only has two readouts. I only have a small, simple little LCD here, but this tells me the right-hand side, the cold side, on the right is 57 Fahrenheit, and the left is 59. And this is the hot side on the left, 195. So yes, my right-hand side is showing a little bit better performance than the left. And I did not replace any of the modules on the left-hand side, but I did on the right-hand side. So I might have to look into that. After 15 or so seconds, it will actually change to this screen. This tells me the return temperature is 88 degrees, and this gives me the voltage that I'm doing from the battery. I put in a voltage divider right from the 12 volts, and I take that and I put that right to my, I can read that then from an analog switch on my Arduino Nano. In fact, this is the printed circuit board. I just decided, in case anybody wants to build this, I will make the artwork available. Just contact me someplace. I can post it on my Thingiverse channel, or I have a couple of places I can post it. Anyway, this is the board. And there is another video out there I made on making printed circuit boards. It's not that hard to do. You just got to gear up with some equipment. The hardest part is figuring out where all the pieces go. But if you get a design such as this, all you have to do is just copy it on a laser printer and iron it on, etch it with ferric chloride. But this is the Arduino Nano. I like using these things because some of my things are just all solar powered. These are really low powered Arduinos, but they got plenty of power for this type of situation. There's a real-time clock on here, and also this is my voltage divider I talked about, because I can put 12 volts right into here, and you can see that I have this divider between 110K and this 51.7K, and the middle of that tap, so to speak, is A6, and that's how I can tell then, because that takes the 12 volt down to a safer voltage, because these are only 5 volt boards, and then I'll really map that output to 0 to 14. That gives me a close representation of what the voltage is. And like I said, if the voltage ever falls below 12, it shuts down, and I've had that happen, so that's a nice little safety thing, so you don't really drain the battery too much. This little board up here, this is the Dallas temperature sensors bus, and these squares here, I just actually put pins in there and make the jumpers go to it. It makes it so much easier to build these things. I don't use the analog power supplies anymore. They're not very efficient. I think this is Texas Instrument, but this is actually just another form of a power supply. I can put 12 volts into it, and it produces, in this case, 5 volts, and it's like 95% efficient. So I really like these little things, and the same TO220 footprint, just like the LM linear series. And what else is going on? Oh yeah, these are the solid state relay controls up here. I just solder wires in them and take them right to my solid state relays. That way I can control off and on, because I don't have it all firing up at the same time. It fires up in sequence. First the fans go on, and then the pump turns on, and then the Peltier, and I can, depending on what I want to do, I can shut them down. In fact, when it goes over under voltage, it only shuts off the Peltier modules and keeps running the water for a while. So, and then this is my LCD hookup, but it's pretty straightforward. And this is actually this board here was actually made for a different purpose, but it's able to just kind of restructure it a little bit. This is the same board that actually runs my the tracker system on my solar panel. And I also, then this is the relay board. I just hook up to it. I'm using these KF0602D solid state relays. And I've only got 3 of them plugged in here, and this extra little pin here. That's a generic footprint for most of these little solid state relays you can plug into a printed circuit board. Some of these have pins here, and some of them do not. That's why sometimes they're connected. This particular solid state relay I'm using does not have this extra pin, so I don't even drill it out. But I love these little solid state relays because you can just put 3 to 5 volts onto the control and it will switch a whole lot of amps. These are not used for the Peltier modules. They don't do that much, but for fans and pumps, and they'd be perfectly fine. Yeah, nothing else on here. I got little LEDs that tell me when it's on and whatever, but pretty straightforward on this one. Um, this is my power coming in from, I have another board out here that controls it, but this is the power line coming from the uh, photovoltaic panels. And this is 10 gauge wire, and I'm running 10 gauge wire to this plug-in device for DC only. This is where I plug my heaters in the wintertime. But then these two wires that coming off that, they go right to my my rover, Renology rover, and this is a 40 amp one I'm using. So, and then these other two wires coming back from the battery. So not only do I get the battery, which drains pretty quickly, this is not to be used at night. This is only going to be used when the sun is shining well, and that's kind of when you need AC anyway on these hot days. Um, but I don't. The display I have on the rover basically it just tells me the percentage of charge, and it usually hangs around 70 to 100%, something in there. Sunny day, this is 100%. It just kind of keeps up with this system, so it's pretty well matched to what I'm using. Um, this is the same whole system, a picture you saw before, putting it back together. Then I did insulate these wires, the hoses, I mean. Just because I don't want any heat sources in here, and these wires are well close to 90 degrees. These hoses are filling with water. Right now, I'm just pumping distilled water or RO water through this. I'll either tear the system down or flush it with antifreeze, a safe antifreeze for wintertime. But yeah, this is going to stay right here. I'll be mounting the heating elements over here on this wall. Right now I use those things. I put them in my kiln. I needed to boost my kiln up to 137 degrees to sanitize the wood for powder post beetles. So I disconnected the photovoltaic panels, hooked them up to that with an extension cord, and that worked great. Let's see here. The heating. Now that's the whole thing. The trick of all these Peltier modules is to get rid of the heat as much as possible from the hot side. So this is the latest one of my heat exchangers outside. I got some of these Titan waterproof fans, 12 volt, and this is a radiator. You can't see it very well from this side where I hook up my hoses to. And then I just welded up this aluminum frame to kind of mount it to the wall. This is the top side of it, and it's nice because these are pre-drilled for fans, or what I'm using, I 3D printed it up some hose or adapters for a pipe. I'll show you here. This is a 3D printed one. This is just sort of in progress. This is my original one. Now this only held 220 millimeter fans, and this did not do a good enough job of getting rid of the heat. Just because my return temperature was 105, 107 back to the board. That was just not removing enough. So I went ahead and added this one. This takes 140 millimeter fans. And by calculating the area, it's like 230% greater cooling capacity. And as you can tell in the earlier pictures of the screen, it actually did a pretty good job of dumping the heat outside here. This particular back wall here does not get any sun. You can see there's a lot of mildew and crap on this, and it's a multi-colored shop. Back when I was extremely poor, local lumber yard had a big back room just filled full of parts of leftover siding, and I think I sided this whole shop for $140 because of the deal they had. But this is how I configured them. These are 5-foot tubes, aluminum this side, because I figured any heat here it's going to act as a heat chimney, which it does. But there's also some netting or screen on the top up here, I'm trying to say, just to keep these areas clean. Because if I just had it just like this, there's already crap sitting on here. So I figured by putting these tubes up here, I'll have 3 more on this side once I finally get the upper brace made. Not only will it help the heat exchange, because then you have a heat chimney, it will also then help keep the radiator cleaner. So I think it's a win-win. But anyway, I'm just tickled pink how well this system has worked. I can, when you walk into this room, you know you're walking into an air-conditioned room. Yes, I mean, it's yeah. There's no way I can say turn it down to 55 degrees and it's going to be great. No, what it does, it kind of holds its own, and that's about it. Okay, last week we had middle 90s here, and yet this was still like 72, 74 with low humidity. Perfectly fine for being in here doing stuff and just hanging out. If I walk out this door, it's close to 80 some degrees and very hot, very humid out there. So I know this is an interesting take on this on cooling, but this has worked for me and I have no problem. So let me know if you need some, like I said, the artwork or something, and I could even make the code available, but you'd have to have all the pins or have the skills necessary to change those parameters. But anyway, this has been an experiment that I'm tickled pink with. Anyway, have a good day.